I don't know. If you make a perfect angle, then we'll say it's not a sketch. That's all. Okay, so I want to double check. Does anyone need this handout? Okay. And I think everybody should have gotten the one before this, the law of sines.
I don't think I have that.
Rub. I have one somehow. I might have two. I don't know. I think I used it to write on, like you can see on the back here. Did you get one from me before, John? Because I'm not going to reference it right now, to be honest.
Yeah.
Oh, sorry, I gave it away. Somewhere I've got more. Somewhere I've got more, but remind me. I will find. I got everything else. Okay, so when can I use the law of sines?
When you have angle sides.
Yeah, when I'm given so assuming I'm given enough information to do anything. If I can make a complete ratio, law of sines will work. So anytime I'm given enough information to do something and law of sines doesn't work, what must work? Law of cosines. So together they kind of like cover every possible situation. And the law of cosines is, well, here, let me write this way. This so far is what? Old Greek dude. Yeah, Pythagorean theorem. And then, so extend it to be all triangles. This is just the adjustment piece. And to be honest, the other two ways to write this is just recognizing that if it's not a right triangle, C could be anything, B could be anything, A could be anything. So the other two ways to write this are kind of stupid. I want you guys to notice. If I had just, instead of calling side C, if I would have just called side C B, then everything would have shifted over. But here's the important piece. Whatever angle's here, its side will be there. And whatever that leaves out, they're here. You guys see that? Now, of course, I'm trying to point that out because this is something else you have to have memorized. Law of sines, law of cosines. Did I give, Christy? I didn't do this, did I? I didn't, no, because we've barely done any identities. So eventually when we get into identities, I'm going to give you guys a big sheet of identities. These are going to be sitting on there, and they'll be in the area of all the ones you have to memorize. And of course, the last one, not to leave them out. So just to show you, a squared, so that b squared and c squared. So these guys go here, and this angle relates to that guy. That's how all three of those work. It's just like if I called the side C instead of B, then I'm going to use the part that's got C in the right place. That's all those are. Okay. So I want to do this. I want to remember anything. Did we actually do all the problems on this worksheet?
We didn't do two because we didn't have.
Good. We didn't have what?
We didn't have line for it.
We didn't have, oh, room for it?
Yeah, on the paper.
Oh, neat. Sounds like a terrible. Well, here's the one with number 2. What's up with number 2? Why did I put this on here? What's up with number 2? This is weird of me. A very weird thing I've done here. What do you guys notice about this? I don't remember. I don't think I did this on purpose. Not to give myself an out, so I'm not going to give myself an out.
We don't have B.
True. Kind of more importantly, can I make a complete ratio?
Yeah.
Yes. So then what law would I use? law of sines. And then you could say, well, Jeff, why did you put that in the law of cosines paper? So just to get them past me a little way out here, I might have done it just because now we know both laws. You have to know when to do which. So let's alter this just a bit. Let's make that B. Everybody, you're allowed to do that. Okay. That might be what I meant, but to be honest, I can't remember. Can you guys help me draw what we know so far? So if we draw exactly what we know, it won't look like a triangle yet until I draw something in that I don't know. So I know the angle B is 88 degrees. And 88's almost 90. So there's angle B. And I know side B would be over here. And just to make this a little more true to form, this will be like, I can call this side C, and I can call this side A. And then this will be side B. So this is angle, what angle is this?
C.
This is angle C, this is angle A. Okay, now did you have to draw the triangle this way? No, but it should have had, and we know B. It should have had the mouth that I'm given in between the two sides of the mouth, in between the whatever you, the upper and lower lip. Sure. So this is a classic cosines problem because it's and you don't have to remember this is side angle side. So you could teach all these based on, is it side angle side? Is it side angle angle? No, bullshit. Just if I can make a complete ratio. But just to point out, that's side, angle, side. So using law of cosines, what could I get?
B squared equals.
Yes, I can only get B right now. Because to do the law of cosines, I do have to know an angle. And the only angle we know right now is B, which means the only side I could get is B, which thankfully is the only side I need. Yes? So then we could do, stay with me now. B squared equals A squared plus C squared minus 2AC cosine B. And then I just plug in what I know. A is 1, that's nice. C is 3. So this will be 2 times 3. Cosine of 88 degrees. Dudular. I'm gonna guess that that's roughly 9.92. No. Yes, 9.92.
9.7.
Damn it. I never go far enough. So real quick, how do I do this? Well, in your calculator, you can put this whole damn thing in there. I need you to understand. I can put, because these calculators cost enough money, I could put 1 plus 9 minus 2 times 3 times cosine of 88 and very quickly make sure I'm in degrees. Oh shit. Yeah, there you go. Cost enough money, it should be able to handle all that shit. Now what does that equal to? What did I just find?
B squared.
B squared. So what I didn't do in my head was to take the square root. But I'm okay with that. Do you guys remember how to take the square root without having to round it all? And without having to type all this stuff?
The answer button.
Square root, yeah, the answer button down here, right above negative. Square root of the answer that always holds the last number that was on the screen. So we get 3.13 roughly. Yeah. Are you guys with me? So law of sines, law of cosines. Yes, you have to kind of memorize them, but then they just become plug and chug stuff. Here's the really good thing. I don't know if you guys really picked up on this. I'm pretty sure I said this before. What sucks about law of sines sometimes? what could happen when you apply law of sines? What do you have to check for to see if there's a potential?
You have one side with two possibilities.
There might be a second triangle answer, or there might be no triangle answers, which is actually kind of nice because then the only possible thing you would put it in, it would say error, and you're like, oh, good, that's the calculator trying to tell me you can't make a triangle out of those pieces. Crazy man. Why is that? Because what is the range of inverse sine? How did we have to chop the sine function? Just remember this. I had to chop them at the lowest and the highest points. So where does that happen for sine? Negative. What is it, negative 1? What angle makes it negative 1? What angle makes sine negative 1? Negative pi over 2 to pi over 2. And then it made this weird little shape that passes the horizontal line test, yes? So listen, I really want you guys with me. Triangle angles go up to 180 degrees. They could be almost 180 degrees, yes? Even if it was 179.99999 degrees, it can still make a triangle. Because it's got a little bit left over for the two angles on the side. Okay. So since inverse sine can only give me angles up to 90 degrees, that leaves the door open that an angle you get is a reference angle. And that's part of the reason why it allows for a possible second triangle. Inverse cosine goes from 0 to pi. And that's 0 to 180. And what angles could show up in a triangle? 0 to 180. That's why the law of cosines doesn't have any possible second angles. It's triangles. Now you could say this goes against my cosine is an asshole thing, but the way I look at it is cosine made sine take the case where you had two answers. So cosine is still an answer. Okay. Are you guys at all with me? Do you actually have to understand what I just said to be able to do the work? Nope. Would it be nice if you understood what I just said? Yep. Okay. Now, what would I have to do to finish this one out? Why am I not done with this one?
You don't know everything.
That's so true. Sorry, that is so true. But what could I use now to figure everything out? What am I still missing? Yeah, the angles. I'm missing these two angles. And how do I get those? I could either use law of cosines again, because now I have enough information, or I could just use law of sines, because can I make a complete ratio? Yeah, totally. So now it's wide open. You could use either one. Can you guys attempt to get angle A using law of sines? Can everybody please find angle A using law of sines? Everybody please. Ethan, did you get this law of cosines? No? Okay. Groove is in the hall. Oh yeah. Alright, here's this worksheet. There's zoom this, but just so you can see what it looks like. And there's the practice test. Thank you for that one. Good. Scheiße. Groove is in the hall. Okay, so let's see. So if I make the complete ratio using B, this is a major approximation, but let's just go for it. Is everybody with me? So now I can make a complete ratio out of B. How do I set this up so I can get angle A?
It would be inverse sine.
Well, I mean, what would I have to write this stuff down first before I could?
What?
What do I put here?
Sine
Yep. Over?
one.
1. Sweet. So now, like Trent said, this I could take the inverse sine of both sides. Now, one thing we know about angle A, is it possible angle A is bigger than 90 degrees? Yeah?
Yeah.
Yeah?
Yeah.
How big is angle B?
Less than 90.
No. Yeah, it's 88, yes?
79.
Right? And how big is its mouth open? Okay, how big is A's mouth open?
1. No.
So let me ask you again. Could this angle be more than 90 degrees? No. All right, so what'd you get when you did inverse sine of all this business? Did you do it? I'm putting you on the spot, man. I'm sorry.
18.620. 2461.
Sorry. Yeah, I heard you, Jayan. I think you were saying. Yeah, 18.62, roughly.
Yeah.
And that answer makes sense. You have to be careful. Even if you're using inverse sine right after you used law of cosines, it could still give you a reference angle answer. So we could have used law of cosines to finish this out. And what's a little bit better of that? So law of sines has got something really big going for it. It's simple. There's not a lot of shit involved with law of sines. You guys with me? But sometimes it'll give you an angle that's not the right answer. Because maybe it says 20 degrees and it meant 160 degrees because it gave you a reference angle. Why would it do that? Because in order to even let the poor dude exist, we had to chop it so it couldn't give us all the possible answers. That's not its fault. It's not its fault. Okay. And then now how do I get angle C?
Just Pythagorean theorem.
No. What do you mean? I got two angles.
Oh, you're right. I meant.
Add them up, see what's left over from 180. Yes, 180 minus what I've got. Okay. Of course. Jeff. Okay. So, what I want to do today, I'm going to do something with you, and then I'm going to let you guys create something yourselves. Maybe, Christine, can you help me? What do you want to give out? Here, give these out. Let them pick if they want to. One of them is from the psychiatric center that I escaped from. I mean,
What are they measuring in the cycle?
how far you are from normal. Here, Christine, did you play with that? They found a rather large number for me. I ran out of the room, so they took a ruler with me. Look at these little baby protractors. I know. All right, so we're gonna do problem together. And then I'm gonna have you guys do one on your own. You're gonna create your own triangles. So everybody's gonna get slightly different answers. We're gonna do this one together. Oh, here. Anyone need some paper? Yes? Sure. If you want like unlined paper, it might make it easier to see your triangles you're drawing. Anybody else? Everybody else is good? Okay. All right. So, this is very exciting. So, a real quick insight into being a math teacher. I know this will work, but it didn't take a minute to try it out to make sure, but we'll find out. Of course it's going to work, because it has to, because that's how math is. Here, this is mine. So I want everybody, first off, let's try out these protractors. Has anyone never actually used a protractor before? Okay. What I have given you is not a standard issue protractor. Oh shit. That's why I can't see it. There you go. I've given you a little tiny baby protractor. We take good care of them. He's doing fine. He's happy. Here's how they kind of work. So let's do this. Can everybody mark off for me 0 degrees? So like plop it down on your paper somewhere and mark off 0 right there, yes? Now it does say 180 also, and that's just in case you want to kind of work a different direction, but let's say that's 0. Everybody with me? Now let's mark off 70 degrees right there, 70 degrees. So just put a little dot there, yes? And what really sucks about this that I'm realizing, oh, this sucks more than I realized. Oh man, we might have to start over. Oh man. Well, I'll tell you this. Let's do this. One thing I just realized, normal size protractors, it's not your fault, little baby protractor. They have a hole right here, so you can actually put a dot right there.
Just get a needle.
So let's do this, you ready? Pick one of your dots that gives you enough room and just position the dot right there. You with me? I like this. We'll do it live. So everybody with me? Put one of your dots. So see this dot down here? Let him just sit there. He's fine. He's okay. He doesn't want to be a part of this anyway. Now put the dots again. Put a dot right here. That's 0 to, oh shit and a half. There we go, Jeff. 0 degrees and 70 degrees. Okay. Now what we have just done, is everybody with me? Please let me or Christine know if you need help, okay. Because I know some of you guys have never used protractor before. So now I know if I draw, and we're going to use centimeters. We're going to use centimeters just to be different. So can everybody, now watch how this works. Can you see how they line up those dots? Yes?
I don't think that's inches.
Really? Oh shit. What kind of, oh man. That ruler is like, sorry, the ruler of America. Shut up, you little ruler guy. Okay. All right, I really want everybody with me. So this right now just looks like it's already a triangle. But what we're gonna do is we're not gonna draw a line all the way through. This is gonna give me a direction. Are you guys with me? So if you already connected your dots, you should have waited. So I'm gonna kind of line these up and I'm gonna draw, let's go out to 3 centimeters, yes? There. So it should look roughly like this. Is everybody with me? I can already see I'm off kilter, but I'll be okay. That's, standard operating procedure for me. And then, if you do the same thing down here, but let's go 4 here, just to be different. So can somebody remind me, what should this be? 70 degrees, there you go. So that is how, so what we've just done, and Jeff, you can freaking label these. What did I say? This is 3 and this is 4? I think so, right? Let's label this before I forget. Okay. All right, let me stop for a minute. Is everybody with me? Is anybody semi-intrigued? Because we created a concrete 70-degree angle. We've not done that yet. We've been talking the shit out of angles. Yeah, they've all been theoretical. They've all been sort of draw 70. Oh, it's about here. And we're like, all right, finally, I've got an actual 70-degree angle. And I've got an actual concrete side lengths off of it. So this problem is just like the problem we just did. Now, before you fill in the last line, if you already did, stop getting ahead of me. Just try to leave it like this for now. Yes? Okay. And you'll see why in a minute. I want this to be, we'll see. Okay. So over here next to this, can you guys help me? I want to predict how long that piece should be. How could I do that? In fact, let me call these, what do you guys want to call this one? It doesn't matter to me. Don't say you call him Jeff. Call him A, B, or C. Which one?
A.
He's A. Who's this one? Somebody else? B. Okay, that's crazy. So then this is angle sweet. Okay. Or maybe you were saying in Spanish, yes, that's an angle, Jeff, but okay. What do I do to figure out the length of side C? That's the side we haven't drawn in yet, yes? Law of cosines. So if somebody gave me these pieces and they said construct a triangle, I could see what's left for me. So if you get into construction, carpentry, anything, you end up using trig insane amounts. You use trig all the damn time. Because you have all these weird, the slope of this and so forth. Constructing freaking ramp to get into the house. You want to make it a certain slope. You want to make it well above. And so there's tons of trig all over the place. Okay. So how do I set up my law cosines? It's got to be the one that's solved for side C. So this is my standard old Greek dude with the little adjustment to AB cosine C. Okay. So let's see. This is cool. I don't know if you guys agree. A squared, is that cool? A squared plus B squared minus 2 times A times B cosine the king of no room, 70 degrees. Okay. And now, again, your expensive ass calculator, you can just plug all that shit in at once. People get in trouble when they forget order operations and they try to do it in pieces. So just plug it all in there at once. Let's see. This is exciting for me. You guys don't even know. 9, 10, okay, good. So is that the side length?
No.
No, it's C squared. So C squared is 16.79, blah, blah, blah. So then I take the square root of that. I get 4.09, so basically 4.1. Since we're doing this by hand, that's pretty close. Now, real quick, if that was 90 degrees, then what should this triangle have been? 3, 4, 5, yes? 3, 4, 5 triangle? So if this was 90, this would have been 5. Since it's 70, this is shorter, because that one side kind of came in towards it. So 4.1 makes sense. It's a little less than 5. That's what I expect. So if you guys check it, take your rulers. Hopefully everybody now has the units that the rest of the world uses. Not us, we're special. So if I put one side here and the other side there, mine, of course, it actually comes out a little less than 4 because my stupid other side wasn't quite right, but it's pretty close. Did anybody get like just over 4? Anybody draw theirs better? Mine is like 3 point, it's basically, yeah, it's like 3.98.
I got a 4.
You did? Okay. You probably did better than me. See this side? See how it doesn't really line up with that? I think when I was drawing it, my poor little ruler scooted. Okay. Do you guys get the feel for, obviously you guys have used rulers before, but protractor, yes? Now, the one I want you guys to do, you're not gonna have to use the protractor first, you're actually gonna use it last. So I want every single one of you to pick different length sides. So, for example, still use centimeters. I'll make 1 by, see, I'm not even caring about the angles. 1 by, Jeff, you're gonna be all right. 7 by, that looks like 6.5. Ooh, that's awesome. So 1, 7, 6.5. Now don't make a triangle like mine. Look how mine sucks. You see it's such a sliver, it's hard to kind of work on the inside. Make a better triangle. Pick your own side lengths. You can pick 3, 4, 5, just try not to let it be a right triangle, yes? Pick whatever side lengths you want. I really well, I'll work with mine. Don't make yours a little sliver. That might make it hard. I didn't really match up here, did I? It should be close enough, I guess. All right, let me or Christine know if you need some help, because you don't do this kind of thing every day. I don't blame you. Mine's questionable. We'll see. hopefully you gave yourselves more room than I did. And then, has everybody got a triangle kind of set up? Have you identified for yourself the side lengths on your picture? Is everybody with me? Is anybody not with me? Does anybody need help? You guys good? Yeah, that last side is the side you're going to have to estimate, because this might not be a whole number. You want to get kind of close. I was lucky, I think, with mine. Okay. Once you get your triangle, like mine, pick variables for each side, yes? And then identify where everybody is. So mine's a little weird. This is C, this is B, this is A. So what I want, is everybody got their triangles set up? Please let me know if you don't. Is everybody good? Everybody good? Okay. Pick an angle and solve for it. On your own triangle, you pick any of the angles and solve for it. Can I make a complete ratio? So what law do you have to use? Law of, in order to use law of sines, I have to be able to make a complete ratio, because law of sines is all about ratios. I can't make a complete ratio because I don't know any angle, so I have to use law of cosines. So I'm gonna figure out A. Just to show an example, I chose to solve for my angle A, so I have to choose the iteration of law of cosines that has a little A dude here, so it allows for the angle A to be there. Okay. I love you guys. We're gonna make it. Hopefully somebody finds this cool. We're actually constructing shit instead of just talking about theoretical triangles that live in our brains. Sorry, I wanted to say, do your theoretical triangles tell you to do things, but then you might worry about them. So let's see. Is everybody got theirs set up? Go ahead and try to solve for your angle, and then I'll solve for my angle, and then we'll see what to do next. Good Lord, that made mine difficult. God. Oh, I forgot to say. Well, we'll see. Hopefully none of you made your triangle way too tiny. You'll see why in a minute. Didn't think about it. I'll show you what to do if you did. Where's that? There it is. I would be really surprised if all of you got like nice whole number sides. One of your sides had to have been freaky. And I should have said something, but most rulers have like split up into 10 for centimeters. This makes sense because metric is based on tens. So this would be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 1. So I mean, whatever your side length is, didn't this come out to be 4.1? So I showed you that already. So I mean, when you measure this last side, it could be 3.4, it could be 5.2. Okay. I'm really close. I'm really concerned. Let's see if I got this right. Now, this is where people really make trick mistakes. I mean, okay, bless you. Please excuse my dumbass son kind of mistakes. So what I'm gonna do, I'm gonna square 6.5, because I don't know what that is. Okay. Pretty sure I can square 7. And then this will be 13 times 7 is 91. So the big mistake people make is they'll add these and then subtract 91. And of course, can you do that?
No.
Yeah, I didn't make that a hard question because I already told you it was a mistake. So it's because this isn't 91. This is 91 cosines. So it's not like terms. So I get 1 equals, what is that, Jeff? I don't know, Jeff. 91.25? Ooh, mine is freaky. Now, of course, you shouldn't be getting the same answers, the same numbers as me, but you're doing the same work. Okay. So then I subtract 91.25, and I get negative 90.25. It seems kind of weird. What have I done? Oh, I left off my negative. There we go. Do. And then I'm going to divide by negative 91. Sorry. So then my negatives cancel. So then I end up with cosine A equals this crazy ass ratio. Is that cool? Divide by negative 91. And then, of course, to get A, I just take an inverse cosine of both sides. And I should get a very, very small answer. Let me know if you get an error. That's not impossible. Oh boy, Jeff. I really set myself up. Let me show you what I mean. So, is everybody, let Christine know if you need help with the steps. Why does my answer make sense visually without actually checking it? Yes! And now if I want to check it, look what I've done to myself. Don't be dumb like me. Be smart. I need to line this bottom up with that bottom of the triangle. And then, that's not too bad. Look, there's 10. So let's see. Oh shit. Line up. There you go. 1, 2, 3, 4, 5, 6. Holy shit! Sorry. That's 7 degrees. I'm sorry. I didn't think I'd get that good. Please keep going. Do you guys see? So when you get your angle, take your protractor and check. Is that the actual angle measure? I want to come around and see everybody's. So give me a moment. Are you still? Oh, what'd you get? Oh, sweet. Let me see. Don't freak out. I'm gonna watch you do it. Oh, it's over there. So what you do for yourself? Put down the base. And now here's where things get trippy. Is that far enough? Yeah, you can kind of line it up. See? Not too bad. And then thankfully this is just far enough. You can probably line up better than me. I'm sorry, I shouldn't be doing that. Oh yeah, it looks pretty good though. Yeah. You can see what I mean. If you pick an angle where the side's not long enough, it might not intersect the outside of the protractor. In which case you just take your ruler and extend a line for yourself. So it goes outside your triangle. At least then it can intersect the protractor. You can see where that angle is. Does that make any sense? That was the one thing I should have been more careful about. But like I said, I'm doing this live. So line up the base and put this on the vertex. Line up the base. There we go. So put it on the vertex and then rotate the line. Yeah. And now that looks almost perfectly 90 degrees. Yeah, there you go. Yeah. That's perfect. Oh man, that takes so much ass.
Very simple.
Oh, okay. Which is great. If you're within like 1 degree, that's pretty damn good for freaking pencil and rulers and freaking program, kidding me? That's serious. Oh, are you worried? What you get?
Well, I got 48.
What do you mean?
It's like almost
where they pushed it over, yeah. But that's pretty close, even with that. How's everybody else doing? Yes, and then subtract from the other side, because the last thing you want to do is divide by this to get him by himself. Yep. So add those together, subtract it, and then divide. Cool. Oh, you made us literally. Oh man. Interesting. You made us literally. Oh, well, that's not gonna work. Then your concrete verification won't be true. So you can do that if you want to. No, subtract, then divide. So it's sort of like if I had 5 equals 7 minus 2x, I would subtract 7. So that's where we are. This equals that minus unknown. So subtract that down. Good. I'm kind of surprised they don't do this more, you know? But it wasn't always that we had protractors we could just grab. Or at least it wasn't always that I knew where they were. How's everybody else doing? Did anybody get like nowhere near? You would intrigue me. I'm really curious about yours. Oh yeah, not divide to get close up that sum.
So cosine would be,
Well, no, divide. Divide by this, cosines. Yes, that's what will make it cancel, and then the ratio sets itself up. And now you see what ratio to feed inverse cosine. Right? So now you know cosine A, don't forget this negative, cosine A equals this, the negatives can cancel right. So cosine equals that, so now take the inverse cosine of that ratio, now being what? Oh wow. Oh, you made a tiny little unit, dude. Okay, sure. Inverse cosine of 0.3. Which angle is it? Angle A? Looks wrong. This is 0.6, this is me see. Here. Trying to, well, here's what you're gonna have to do for yourself since you have such a tiny triangle. You have to extend the sides. So like, try to line it up so you can extend the sides. So then you can see it better. You might be able to see it here. Because you can kind of. Yeah. Oh. The problem is, it's so small that if we're off by only one, it throws everything really off kilter. Yeah, that's why we don't want to make them quite that Hispanic. But at least you get the idea. If we make way too small of a triangle, then our error in measuring becomes worse. Okay, how did everybody else come out? How did it come out, Ronnie? Oh boy. These are both 500.
This is not my rounding because it's like this 25 and 5 0
Oh, here's the problem.
Yeah.
You actually found no. Here's the problem. This is
That's what I'm doing. Yeah, so
All right.
you're a sine of 48.
This is C or B,
Right.
right? That is C or B. And if you want to put angle A, it has to be side. So what you really found is either C or B. And this, you see that side, this has to be the side that goes with that angle. So what it starts with, what it ends with, has to be the same. So this is really like C, for example. So measure C real quick. The protractor. And this 90 the reverse, the other numbers, but line up the bases. There you go. Oh, look at that. Freaking 30 degrees. That's what you got, right? Kick ass. All right. So you just, yeah, okay. Unfortunately, I don't think that's what's happening back here, although maybe it is.
Yeah.
Is that what's happening back here?
Wait. Okay, okay,
First side.
so how do I set this up again?
Put A here. Yeah, shit. No, oh yeah, you did. You said this is angle A. So
I know.
this is gonna be side A. So these should be. Yeah, okay. Now I
No,
feel
no.
better.
4800. Yeah, sure.
Okay. Let everybody talk for a bit. It's okay.
Wait,
It's
how I
rotate. Like this is supposed to be.
Oh shit. Well, they just changed the letters.
Yeah.
So let's see, yeah. This side should go with, oh boy, it should be B. Or that should be C. Yeah. So what you're actually solving for here is angle B. So does that match if you check the angle B? Is it 88? Oh, you did? Alright, but now you see the mistake you made.
Yep.
So mouth has always gotta go with its destinies. That's a life lesson.
Makes sense.
Yeah.
Don't say that carefully. Yeah.
It is under parentheses.
Kick ass.
Yeah.
That shit.
This is the parentheses for the sine.
curious about your other angles, you do that. So you don't make Does this help at all? I mean, it's interesting that I kept talking about people give you side lengths and try to make a triangle, and I figured let's actually do that. Let's actually make a triangle. Okay. Now, can you imagine to try to figure, if I gave you 3 side lengths, do you understand why that would be really hard to create? If I just gave you 3 side lengths, say I want a triangle that's got 5 centimeters, 7 centimeters, and what do you got, Jeff? 11 centimeters. Yes? Do you understand why that would be difficult to do? If you put 5 and 7, you have to give yourself somehow enough wiggle room so that you can make 11 fit. So you'd be doing a lot of erasing or some kind of like place holding so you can kind of move it and then check. Yes. So you might even need to use 2 rulers. That would be a good idea. Yeah, one ruler would show this side, and you can move that, and then the other ruler would show you the 11. I don't know if you guys are with me or not.
They just made a double.
Can I just try it? Do I have another ruler up here? No. Man, I just got the crappy one that's. It was America shot. All right, that's all right. But what I'm saying is, you would put like, you would draw 5, and then you would have this sitting here at 7, and then you have another ruler, so you would rotate this until the other ruler says, "Oh, I can fit 11." Okay, good. Not as simple. That's why I didn't say to do that. All right. We're actually done. So this is good because I was hoping we could get to a point where we could potentially start to look at the practice test. Unless anybody has questions, or we could do another example. We could do the problem from the practice test. Yes? Huh? Okay. So, does anybody open to just doing these 2? Actually, it's already 2:15. Is that right?
Yeah.
Damn. All right, let's do this. We'll work on the practice test tomorrow. Yeah, I didn't realize it was already 2:15. That's crazy. Time flies when you're playing with protractors, kids. All right, so let me get everything back so I don't have to try to. Could you, if you had one of your sleeves, your plastic bags, put your little baby protractor back in there. They're little babies. They're little babies. I didn't get my psychiatric. Yeah, you guys know what the test is?
Right.
Come on Friday. I won't be. This Thursday. That's why I do the practice test. Tomorrow's the review day. Oh. Thank you. Hey, tomorrow. See you, Trent. Oh, that's good. That went pretty well. I knew it would work. I just hate doing something I didn't sit down and do myself ahead of time, but oh well, it worked.